Now it's your turn to graph the equation 2x minus 5y equals 30 by first algebraically solving this equation for the slope-intercept form. If you've not tried this problem on your own in the lecture notes packet first, please pause the video, return to your lecture notes packet, complete this problem on your own, then return to the video to verify that you've done this problem correctly. Our first step in graphing this equation is to solve it for the slope-intercept form. To solve the equation 2x minus 5y equals 30 for slope-intercept form, we'll begin by subtracting 2x from both sides of the equation. This will leave us with negative 5y equals negative 2x plus 30. The final step in solving negative 5y equals negative 2x plus 30 for the slope-intercept form is to divide both sides of the equation by negative 5. On the left side of the equation, it simplifies down to y. So y equals, on the right side we need to make sure we distribute dividing by negative 5 into both terms. So negative 2x divided by negative 5 becomes a positive 2/5 x, and 30 divided by negative 5 becomes negative 6. Now that the equation is in slope-intercept form, we can begin to graph it. As always, we will begin by properly setting up our axes. We need to draw both the x and the y-axis with a ruler. We then need to put arrows on at least the positive ends of the axes and label the axes x and y appropriately. And then we need to pick a scale. Now before I begin to set the scale on the axes, I'm going to look at the numbers that we're dealing with. I can see from my equation the minus 6 at the end is telling me the y-intercept is 0, negative 6. And the 2/5 in front of the x tells me the slope is 2/5. If I go back to the graph and try to space it out using a scale of 1, 2, 3 on both axes, 0, negative 6 will be on the very bottom edge of the graph, and I will be able to count up once, up to the right 5 with the 2/5, but I won't be able to fit a third point onto the graph. To save myself having to erase the axes, what I'm going to do is still pick a scale of 1, 2, 3 on the x-axis, but I will pick a scale of 2, 4, 6 on the y-axis. By picking the scale of 2, 4, 6 on the y-axis, I will still be able to plot 0, negative 6, but now it won't be on the edge of my graph. And from this point, I still need to count up 2 to the right 5, but we need to remember going up 2 really means going up 1 tick mark. So up 2 is 1 tick mark, and then to the right 5 tick marks, 1, 2, 3, 4, 5. So it gives me a new point over at 5, negative 4. We also need to remember that 2/5 is the same thing as negative 2 over negative 5. So returning to the y-intercept, a slope of negative 2 over negative 5 from the y-intercept would mean down 2 and to the left 1, 2, 3, 4, 5. But again, we need to take into account the scale on the y-axis, that a count of 2 is still equivalent to 1 tick mark. And now we can again line up a ruler and complete the graph by drawing in the line. As a final step, we'll just add the arrows on both ends of the line, again to indicate this line does extend in both directions forever.